Alright guys, so now you should have in front of you your note regarding the section 5.2 exponential function. And an exponential function is nothing more than just a function written as f of x equal a to the x, where a is what we call the base and x right here is what we call the exponent. Now, we can also use, instead to have the base as a number, like 1, 2, 3, 5, 7, whatever, we could use another number, which is the letter e. E represents a number, it's the Euler constant, and it's an irrational number, meaning its decimal continue forever without no pattern. So just try to remember that the base could be also defined as e, and e is a number. E is a number, okay? Now, if I want to solve exponential equation, I'm going to use the following property, and the following property is a to the x equal a to the y, and if I have the same base, that means that my exponent will be equal to each other. Okay? So same base imply the exponent are equal to each other. So when I want to look at the example number 3, which is 25 to the x plus 1 equal 125 to the 2x minus 3, what I may want to focus on is 25 is the base, let's call that the base number 1, and 125 is the base number 2. And what I'm looking for is to transform each base. Okay, so what I'm looking for is to transform each base to have the same base at the end. Same base at the end. And for that, I just need to look at 25 and 125. Well, 25 is 5 square, when 125 is 5 cube. So my expression goes from a 25 to the x plus 1 equal 125 to the 2x minus 3, using my parentheses, to the 5 square to the x plus 1 equal to the 5 cube to the 2x minus 3. From there, I'm going to use one of the rule of exponent, which is a to the n to the m is supposed to be equal to a to the n times m. So far, 5 square to the x plus 1 is going to become 5 to the 2 times x plus 1, and 5 cubed to the 2x minus 3 is going to become 5 to the 3 times 2x minus 3. Now, we do have the same base. We have the base 5 and base 5, so we can definitely write that 2 times x plus 1 equal 3 times 2x minus 3. I'm going to distribute my 2x plus 2 equals 6x minus 9, and then I'm going to subtract 2x this side, and I'm going to add 9. By doing so, 2x disappear right here, and 9 disappear right there, and so now I have a 4x, only x on one side. The variable x is on one side, and on the other side of my equation I have all the non-variable, which is 11, and so now I can definitely say that x is equal 11 divided by 4. Alright guys, so let's try to graph this function. I'm going to ask you to take your graphic calculator and try to graph the function, graph f of x equal 2 to the x, and the function 2 times 4 to the minus x plus 1 minus 3. Please, 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 when you are going to graph the second function, please don't forget to put your parentheses, right here. And obviously what you should have on your calculator is 2 times 4, and probably you are going to have a little square box opening right here, and when the square box is opening, you can definitely start to be able to write your open parentheses negative x plus 1. Then you go down and you pay attention, because if you're not paying attention, the minus 3 is going to write right here. So if you think, if I'm correct, you're going to push the arrow down to have the little box going down, and then you will be able to write negative 3. Okay? You may want to do exactly the same thing with the graph of negative e to the x minus 8. Again, please don't forget to put your parentheses right here, plus 4. And now let's try to solve the example number 4 together. So if I want to solve the example number 4 together, I'm going to rewrite 25, which is 5 squared. So 5 squared to the x equal 5 cube. And so now, using my rule of exponent, I'm getting 5 to the 2x. The rule of exponent is a to the n to the m is equal to a to the n times m. So now I got 5 to the 2x equal 5 cube, and I'm supposed to have, as an answer, 2x equal 3. And so x equal 3 divided by 2. Okay? Pretty easy, right? So now let's take a look at the example number 5. It's based on the same idea, okay? Exactly the same idea. What do we have? Well, we have 1 over 3, which is to the x, which is a fraction. And usually we do not like work with fraction, especially when the other side is not a fraction. So what I want to do first is try to change 1 over 3, and 1 over 3 is 3 to the negative 1, right? Why? Because I should remember that my rule of exponent of 1 over a to the n equal a to the negative n. So far, I got 3 to the negative 1 to the x equal 81. And let's continue to focus on the left side of this equation. A to the n to the m is supposed to be equal to a to the n times m. So I'm going to have 3 to the negative x equal 81. Now, I can see that the base is 3. Okay? So it would be nice if on the other side of my equation I had the same base. Well, it appears that 81 is also equal to 3 to the 4th. Okay? If you have 3 to the 3 square times 3 square, and 3 square times 3 square is supposed to be equal to 3 to the 4th. And why 3 square by 3 square? Because 81, it's 9 by 9. At the end of the day, we are now able to write that minus x equal 4, negative x equal 4, and so x equal negative 4. Okay? Let's try again to do the example number 6 together. We have 8 as a base. So 8 is supposed to be a 2 cube. 2 cube is supposed to be equal to 8. And 2 to the 4th is supposed to be equal to 16. So at the end of the day, using my rule of exponent, I got 2 cube to the x plus 2 equal 2 to the 4th to the x minus 3. I'm going to use my parentheses. And then I'm going to use my rule of exponent, and I'm going to rewrite again right here, a to the n to the m equal a to the n times m. I multiply the exponent together. So 2 to the 3 by x plus 2 equal 2 to the 4 times x minus 3. And now I have the same base, exactly the same base. So I can use when you have a to the x equal a to the y. Now I have the same base, so I can write x equal y. So I'm going to do exactly the same thing. 3 times x plus 2 equal 4 times x minus 3. I'm going to distribute 3x plus 6 equal 4x minus 12. And I'm going to subtract 3x. I could subtract 4x. I decided to subtract 3x for one reason and one reason only. I will have to add 4x and minus 3x, and I'm going to have plus x. So x will be already positive, and I'm going to add 12, and I'm going to add 12 to have only the variable on one side and the other non-variable on the other side. At the end of the day, I can realize that the x and the 12, the 3x and the 12 have cancelled out, and I end up to have an 18 equal x. Alright guys, so we've done some example. Now it's going to be up to you in class to do this example. Please, I'm sorry, in class what you are going to do is the problem listed on Blackboard. So please try to do this example again one more time, making sure that you know your rule of exponent. And I would like to remind you some of the rule of exponent. The first one is going to be when you have a to the n to the m is going to be equal to a to the n times m. When you have a to the negative n, it's supposed to be equal to 1 over a to the n. The other one is going to be a to the n times a to the m. When you have the same base, you're going to have a to the n plus m. What else? Sometimes you have to deal with the nth root of a is supposed to be equal to a to the 1 over n. And hopefully I did not forget anything. So what I'm going to ask you, because I've done most of the example in this section, I'm going to ask you to do some of the problem on the practice problem, even though you are going to do some in class. So I'm going to try to do the problem number 7, as well as the problem number 11, okay, and 32. Thank you, and talk to you in class soon.